Okay, let's talk about something that affects all of us, water. Specifically, how we predict what our water resources are gonna do. Because lately, it's getting a lot harder, especially when the weather gets extreme. Today, we're gonna break down a really fascinating paper that proposes a brand new way to predict floods and droughts, all using a clever statistical technique and a team of specialized AIs. So let's see how they did it. Our story starts right here at the Huai Nam Sai Reservoir in southern Thailand. And this isn't just some random spot on a map. No, this place is a real-world lab for a challenge that communities are facing all across the globe. How in the world do you manage your water supply when you can't predict what the weather's going to do next? So here's how we're going to walk through this. First, we'll look at the core problem, the reservoir's dilemma. Then we'll get into their big idea, which they call splitting the data stream. After that, we'll see how they put together their team of AIs, or assembling the AI forecasters. And of course, the most important part, putting those models to the test. Finally, we'll talk about what this all means for the future of forecasting. All right, first up, let's really dig into the stakes here and understand what we mean by the reservoir's dilemma. You know, the heart of the issue is pretty simple. Climate change is basically cranking the volume knob on our weather all the way up. We're seeing more intense rain, which leads to more devastating floods and longer, harsher droughts. And if you're the person managing a reservoir, your job just got exponentially harder. The old rulebooks for forecasting, they just don't work anymore. And this is a direct quote from the researchers themselves, and it really hits the nail on the head. Getting these predictions right is both incredibly difficult and absolutely necessary. This isn't just some academic thought experiment. We're talking about predictions that protect cities from flooding, keep water flowing to farms and homes, and even save entire ecosystems. So you might be asking, how did the researchers even begin to tackle this? Well, their whole strategy started with one brilliant idea. What if, instead of treating all weather the same, you split the data stream? The tool they use to do this is a statistical method called Quantile Regression. Now, the analogy here is perfect. If you just look at the average water flow into a reservoir, you're missing the whole picture. You don't see the dangerous spikes or the devastating dips. Quantile Regression lets you slice up that data, kind of like a triage nurse, so you can separate the minor scrapes from the critical emergencies and focus only on the extremes. It's about finding the signal in the noise. So they took 18 years of historical data from this reservoir and did exactly that. They used quantile regression to create two totally separate streams of information. In one corner, you have your normal, everyday, predictable water flow. And in the other, you have the heavy hitters, the extreme events, those rare, high-impact floods and droughts that cause all the real damage. Okay, so now they've got their data split into two specialized streams. The next logical step? Build a specialized forecasting team for each one. It's all about assembling the right AI forecasters for the right job. And here's the lineup they picked. They chose 4 different machine learning models, and each one has its own special talent. You've got Random Forest and XGBoost, which are awesome at finding really complex relationships in data. Then there's LSTM, which is a rock star at understanding patterns over time. And they threw in a more traditional model, multiple linear regression, to act as a kind of baseline. They're all pattern finders, they just do it in different ways. And this slide, right here, this is the core of their entire breakthrough. Instead of just one AI trying to predict everything, they created these hybrid models. It's kind of like a football team, right? You have your offensive specialists and your defensive specialists. Here, one AI becomes an expert on only extreme events, while another AI trains only on normal, everyday conditions. Then you combine their two specialized forecasts, and what you get is a much, much more accurate prediction. So the theory sounds great, doesn't it? It's a really clever idea. But did it actually work? Was this new hybrid approach any better? Well, it was time to put these models to the test. And believe me, they were thorough. They set up this massive tournament, testing 16 different combinations of their models. They made the standard single AI approach compete against their new specialized hybrid models. And they didn't just do it once. They did it for forecasts 3, 6, 9, and even a full 12 months out. And the results, well, they were just incredibly clear. As you can see on this chart, the hybrid models, the ones that split the data first, were way more accurate. Their average error scores, which you want to be as low as possible, were consistently better. In simple terms, their predictions were just a whole lot closer to what actually happened in the real world. This graph from the study just illustrates it perfectly. That blue line, that's the real-world water level that was actually observed. And the orange line, that's the hybrid model's prediction. I mean, look at how closely it tracks the real thing. It's capturing those peaks and valleys with amazing accuracy, even months ahead of time. It's really impressive stuff. Now, what's really fascinating is that there wasn't just one supermodel that won every single time. This table shows you the best performing hybrid model for each different forecast length. For a 3-month forecast, this XG-MLR 75 combo was the champion. But for 6 months out, a different hybrid took the crown. The big takeaways here is that the best tool for the job actually changes depending on how far into the future you need to look. It really drives home the power of this custom-tailored approach. Okay, so this experiment in Thailand was a huge success. But what does it mean for the rest of the world? Let's zoom out a bit and think about the future of forecasting. The bottom line is, this research isn't just about one reservoir. It's a blueprint. It's a whole new strategy that can be used by communities all over the globe to get a better handle on these hydrological extremes. It's a powerful new tool for an era where, let's face it, climate uncertainty is the new normal. At the end of the day, as the researchers put it all comes down to one thing. Better predictions lead to better decisions. If you can forecast more accurately, you can plan more effectively. And that translates to saving crops, protecting homes and businesses from floods, and doing a much better job of managing our most precious resource, water. And so that leaves us with this one big, hopeful, and really urgent question. This work shows that the tools are getting so much better. We are actually becoming capable of predicting these extreme events with a kind of accuracy we've never had before. So the question isn't just, can we predict them anymore? It's, now that we can we finally, truly prepare for them?